An office building worth $1 million when completed in 2003 is being depreciated linearly over 50 years. What will be the book value of the building in 2017 and 2018? Assume that the scrap value is $0. So we didn't give a whole lot of background on this, but basically, if you think about it, okay, we're starting off with an initial value. The building is worth $1 million. So we could say, okay, you know, X equaling the number of years after 2003, and worth of the building is my Y. So in 2003, which means there's no years past 2003, I'm at 1 million. Yeah, there you go. It says it's depreciating linearly over 50 years, which basically means at year 50, we expect this building to be worth nothing. So we want to figure out what would the depreciation be. What's the rate going on here? So basically we have two ordered pairs. We have 0, 1 million, and we have 50, 0. I want to get a rate of change. A rate of change is just another name for a slope. So I want to get a slope for this. So the slope is going to be 1 million minus 0 over 0 minus 50. So I'm going to have 1 million over negative 50. And 1 million over negative 50 is a negative 220,000. So basically the building loses $20,000 in value per year. And we have an equation that would predict what's going on here, since I know that this is a y-intercept, because the x value is 0. So I know that, I have the slope, I have the y-intercept. So the equation of my line, y equals negative 20,000 x plus 1 million. So now it's asking me for the value of the building in 2 different years. So essentially, the way I defined it is that, okay, well, in 2017, that means that x would have to be 14. So, and this is actually going to take the place f of x, if you want to. So I'm going to figure out what f of 14 is for 2017. So negative 20,000 times 14 plus 1 million. F of 14 equals $720,000. 2018, no doubt, means that x is going to be 15. So f of 15 is going to be negative 20,000 times 15 plus 1 million. So f of 15 equals about $700,000. So there you go. Kind of a roundabout way of asking you a question and giving you some coordinates, but that's how they will sometimes do that in real life scenarios. You'll have these data that will help you define your line, and it's all right there. You just have to know how to make use of it. But as I said, a lot of these kind of graphs usually are not extremely linear either. So not entirely an overly realistic circumstance, but still, headed in the right direction as far as the real worldness goes.